Okay, guys, sections 8.5 and 8.6. These last two sections are going to talk about fundamental counting principles and probability. You will have word problems, guys. All of this stuff is going to be word problems. And the only way that we get better at this and that you can really truly understand is to practice. So the notes are just presenting the ideas, the information. And then when we practice, I'm going to give you a bunch of practice, you'll be able to decipher what the questions are asking and how to answer them and that sort of thing. But you are absolutely going to have to think, and you're absolutely going to have to pay attention to what the questions are saying, the wording of it. Now, you will have your calculator, graphing calculator, scientific, doesn't matter. You will have it. I'll show you how to do some stuff in your calculator to make your life a little easier. There'll be a couple questions from 8.4, probably not a Pascal, it's just one of the binomial coefficients, that sort of a thing. And then the majority of stuff will come from this. So these first two questions, I just want you guys to think. I want you to look through these, we're going to talk through these. This is just kind of introducing the counting principles that you're going to be seeing. When you talk about probability is the likelihood of something happening. You can list out likelihoods, or it's not always like a percentage of rain or something like that. But there's different ways that you can figure things out, putting things in pairs or putting things in groups. You can list them out and say, okay, there's a million different ways. But if you guys are wondering how they calculate like the chances of people winning the lottery and stuff like that, those are the things we're going to talk about now. If you read this first question, it says 8 pieces of paper are numbered from 1 to 8 and placed in a box. One piece of paper is drawn from the box, the number is written down, and the piece of paper is returned to the box. Then a second piece of paper is drawn from the box, and its number is written down. Finally, the two numbers are added together. How many different ways can a sum of 12 be obtained? All right, there is a ton of information here. The first thing I'm going to tell you guys to do is write down as much as you can. So you have, how many pieces of paper? 8, and they're numbered from 1 to what? 1 to 8. So you have 1, 2, 3, 4, 5, 6, 7, and 8. All right, now let's talk about this for a second. You yourself, you're this person in this problem. You draw a card. You pick it out. You look at it and you do what? You write down the number. And then what do you do with the piece of paper? You put it back in the box. It's returned to the box. So how many pieces of paper are left in the box for you to draw again? There's 8, right? Okay, so this is the first time you pull, and then this is the second time. All right, so that's important information because it didn't say that you put the piece of paper on the floor, because if you put the piece of paper on the floor, then how many pieces would be left in the box? 7, okay? So it changes. Then, let's read what it says. The two numbers are added together to get what number? 12. It doesn't say to get 12 or more, which would be 12 or anything higher. It doesn't say less than 12. It says just 12. So what are the possibilities that you could pull a card out, write the number down, or paper, whatever it is, and then do the same thing, pull out a second time, and when you add those two numbers together, you get 12. What are some possibilities? What would you have to add? Can you add 1 to anything? No. How about 2?
No.
How about 3? No. Okay, so none of those will work. How about 4? What happens if you pull out a 4? You could pull out an 8 the second time. Agreed? Okay. What else could you pull out?
5 and 7.
You could pull out a 5. What else could you pull out? 2 6s. Okay. What else could you pull out the first time?
8.
Okay, you could pull out an 8 the first time, and what would you have to get the second time?
4.
A 4. Good. And what's one more that we missed? 7 and...
5.
So how many different combinations do you have here?
Are they the same?
Well, you're pulling you're pulling the first time you get this versus the second time. All right, so let's just look. We're just kind of we're not solving this problem in any specific way. I want you guys to just think. We're listing out the possibilities. So Brian brings up a good point. Isn't 4 and 8 the same as 8 and 4? Yes, but if the direction, so there's 5 different possibilities here, right? What about if they say the order doesn't matter? It doesn't matter if you pull out a 4 first or an 8 first. Then it would only be 3, correct?
Yeah.
Okay, good thinking. That's good. This is just thinking. We're just thinking. I want you guys to just see this. Now look, the second scenario. Same thing. I have 8 pieces of paper. 1, 2, 3, 4, 5, 6, 7, and 8. It says 2 pieces of paper are what? God bless you. What does it say? Are drawn at the same time. And the numbers are written down. Now, how many possibilities could there be if the numbers are drawn at the same time?
3.
You could get an 8 and a what? 8 and a 4, right? What else? At the same time. 7 and or 6 and 6. Now, that appears to be almost the same kind of question, or the same question. But when the wording is just a touch different, it changes the outcomes. A lot of these problems that you guys are going to come in contact with, God bless you, it's going to use the terms with replacement or without replacement. And that's a big deal. You guys will see it a lot with cards. You'll see it a lot with marbles. So you have 10 marbles in a bag, right? 10 marbles in a bag. And you're drawing 2 marbles. You pick a marble, hold on a sec. You pick a marble out, look at it, see what it is, put it back in. What is the number of marbles that are in the bag? 10. You have 10 marbles. You take a marble out, you look at it, you throw it as far as you can. How many marbles are left in the bag? 9. This would be with replacement. The denominator will stay the same. This is without replacement. I know it seems, oh, it's not a big deal. It makes a huge difference when you're calculating stuff. Jordan, question.
Why did you, for example 2, why did you do 2 rows? Like, isn't it only 1 round of picking pieces of paper?
2 pieces of paper are drawn at the same time.
From 1 through 8, right?
Right, but there's 2 pieces of paper that you draw at the same time. So what could you draw? What I'm saying is, what could you draw simultaneously? You could draw a 4 and a 7 out. You could draw. Oh, I see what you're saying.
Draw a 6 and 6.
I see what you're saying. Yes. Yeah, you're right. If you're drawing, you can't draw the 6 and the 6 at the same time because there's only 1 6. I see what you're saying. You guys have got to be really careful with wording. That's where you guys are going to get tripped up, not the calculation part. It's the wording. So let's look at this. There's going to be a few different kinds of problems that you're going to talk about. We're going to talk mainly with the fundamental counting principle today. Fundamental counting principle. All that means is we're going to multiply. When it asks you to find the number of ways something can be done, you multiply. You'll see questions that say, you have the choice. You go to dinner. You can choose 3 appetizers, like 3 apps, 4 entrees, and 2 desserts. How many different options can you have? How many different meals can you make? How would you figure that out? You would multiply 3 times 4 times 2. You'll see this with, they'll give you questions where they say, you're picking your schedule. And you want to pick 1 of 4 math classes. There's an option of 6 sciences and 14 electives. How many different combinations can you make? You would just multiply those together. That's the basic part of the fundamental counting principle. sometimes it's easy to list those things out, kind of like we did with the cards. We could say, okay, here's the option. Here's what could possibly happen. Sometimes it's harder to do that. In questions like this, and again, I'm going to present all the information to you, and then over the next several days, we're going to practice this, and it'll become easier, I promise. How many different pairs of letters from the English alphabet are possible? All right, different pairs. First of all, how many is in a pair? There's 2, right? And how many letters are in the alphabet? 26, okay. Good. It's not just 26 times 2. Because think about it. How many different? Well, you could have A with A, right? You could have A with B. You could have A with C. You could have A with D, right? And go on and on and on and on, right? But then you could also have B with A, B with C. That's not the same as A with C. You understand what I'm saying? It would be impossible for you guys to list out all of the different possibilities and count them all. You're going to miss some. You're bound to miss some. So this is how we're going to solve these. We're always going to think about possibilities. Always, I want you to think about possibilities. So again, how many are in a pair? 2. All right, so there's 2. We're talking about 2 possibilities, right? We're talking about a pair is 2 spaces, we'll say. How many letters are possible to fit in that first space? 26, correct. How many letters are possible for the second space? 26. So what do we do with those 2 numbers? We're going to multiply. What's 26 times 26? 676. So there's 676 different ways. Now, how can this question be changed? What if they said that the letters could not repeat? They say they cannot repeat. All right, well, let's think about that. There's still two spaces for a pair. How many possibilities are there for that first spot? 26. But if they cannot repeat, 25. There you go. So you're always going to have some stipulation. The math is not going to trip you guys up. You're going to have a calculator. It's understanding, can I use this? Can I not use this? What are they telling me? Yes, ma'am.
How do you know it's 25?
Because once one is already, if you used A, then you know you can use any other thing but A, because it says that can't repeat. So if it was a C, you could use any other thing but C. And again, the more we do that, you're looking at me like, what? It's gonna take time. You guys are gonna have to understand, if something can repeat, the number stays the same. If it can't repeat, it'll decrease by 1 or whatever. Well, I'm just going through some possibilities. This is probably the hardest day, and then the more you go through this, you'll be like, oh, okay, I get it. You start to see things repeat. All right, telephone numbers. You guys are familiar with telephone, right? Telephone numbers, boys. You guys are familiar with telephone numbers. Telephone numbers have 10 digits. So let's put our spaces out. All right, the first 3 are the area code. You guys familiar with that? 954, 786, 305, whatever. So this question says that the first 3 of the area code, 7 is the local telephone number. How many different telephone numbers are possible within the same area code? So this does not apply because it says the same area code. So I have 7 spaces here.
It says each area code.
No, because they're just saying like
Okay.
that. What that tells you is that the area code is the same. Yeah. All right. It says that you have how many numbers to choose from? 10 digits. Okay. Think about what a digit is: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Sometimes they'll tell you can use the digits 2 through 8 or something like that. So you have to count them. All right. So let's read. Note that at this time, a local telephone number cannot begin with a 0 or a 1. So that just gave me a stipulation. What can this first one not be?
0, 1.
Can't be 0 or 1. So how many possibilities are there to choose from if it can't be 0 or a 1? There's 8, right? There's 8 different numbers that could go there. It could be 2, 3, 4, 5, 6, 7, 8, 9. Does it give you any other stipulation about any other space? No. Does it tell you that numbers can't repeat or anything like that? No. So how many possibilities are there for this second space? 10. What about for the next one? Then. And with the fundamental counting principle, guys, what do we do with all those numbers? You multiply. So how many different numbers can we create here? 8 million? Now, if they gave you another stipulation that said the digits cannot repeat, then it would be 10, then 9, then 8, then 7. It's really, really, really important to pay attention to the wording. Any stipulations. You guys will see some on your WebAssign that it'll say you have a PIN, a 4-digit PIN, right? So if I think of a 4-digit PIN, how many spaces am I writing out? 4. 1, 2, 3, 4. And I tell you that the last number has to be even. All right, how many digits are we talking about? 10, right? There's always 10. Unless they tell you, because you include 0. So the first space could be any of those 10. Could be any of those 10, the second one. But what's the stipulation for the last number? Has to be even. So of the 10 digits, how many of them are even? There you go. So it'd be then 5. They might tell you that you have a 4-digit PIN and the first number has to be a 1. If it has to be a 1, then what's the only possibility for the first one? 1. Like, you just have to pay attention to the wording. That's where you guys are going to get tripped up, not by the math. Let's keep going. Now, you guys have your calculators handy? Okay, we're going to talk for a second here about something called a permutation versus a combination. Have you guys seen the C one before? Yeah, that's how you calculate the binomial coefficient. It's also called the combination. I want you to write this down, and I'm going to say this 100,000 times. In a permutation, order matters. In a combination, order doesn't matter. When you guys take your test, you're going to have to ask yourself these questions. Permutation is when order matters. You will see questions about permutations when they ask you running in a race. When you guys run in a race, is there an order? Does order matter on who wins? Who gets first, second, third? Yes. If you are asked about how many different ways an election could come out, like if people are running for secretary, president, vice president, and treasurer, does order matter in that case? Or does everyone have the same job, or are you running for different jobs? Different jobs, so order matters. If you go to the movies and it says how many ways can you and 5 friends sit in the last row of the movie theater? Well, think about it. Somebody has to sit in the first seat, right? And then somebody has to sit in the second. You can't all sit in the same seat. So when I say order matters, it's that there is a, how do they say it here? Different elements is in an ordering of the elements, meaning first, second, third, or somebody has a primary job, somebody else has a different job, all doing a combination, and I'll show you how to do this in the calculator in a minute, would be like if I'm picking a committee. If we have a prom committee, right? I want 10 people on the prom committee. Does it matter if I pick Brian first and Juan second? No, because they're all doing the same job. It doesn't matter what order you pick. So that's the main question you're going to have to ask yourself. So if I look at this, something like this, it says how many permutations? Okay, so first of all, we know this is a permutation because it says the word permutation. How many permutations of the following letters are possible? How many different ways can you write these letters? How many letters are there? 1, 2, 3, 4, 5, 6, right? All right, how many options could go in the first spot? 6, all right? So once one of those letters is accounted for, then how many are left? 5, okay, then that one's accounted for, so how many are left? Then. Have you guys seen something like this before? 6 times 5 times 4 times 3 times 2 times 1? What is that called? Factorial, like this. Grab your calculators. If you have a scientific calculator, find the PRB button. When you hit the PRB button, it says like NCR, NPR, and then the factorial. So you could hit like 6 and then hit that PRB button. Just hit 6. Jordan, I'll talk to you guys 1 sec about scientific. Hit 6 and then hit Brian, hit 6. Yeah, and then hit PRB. And then scoot over to the exclamation point. So that's how you can do factorials. If you have a scientific, we'll go over this again. A scientific, you should just look for the PRB button. This will be, it's on there, I'll show you. If you have a graphing calculator, find the math button, like top left, mid left. And then you can arrow over to prob. Are you guys with me? And then it has the NPR, NCR, that sort of thing. So you're going to be able to use your calculators. You're going to be able to find the binomial coefficients. If I said to you guys, calculate this, hit 10, then hit your PRB button, or some of you have like shift, NCR, whatever, the C will come up, and then put a 5, and it'll calculate it for you. You don't have to do the whole formula and all that stuff. Again, we'll go over this more in the next several days, but all of this stuff you can do in your calculator. You just have to know which one you're going to use, the C or the R. Whenever there's an order, you use the P. So here's an example of when you would use a permutation. And you can look at this a couple different ways, but it says 8 horses are running in a race. How many? 8. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. How many different ways can the horses come in what positions? First, second, and third, right? Do I care about any of the other spots? They want to know how many different ways can the horses come in first, second, and third, right? Well, how many possibilities are there for the first place? 8. There's 8 horses. Of those 8, one of them's going to come in first. So once somebody comes in first, how many are left for second place? 7, and then 6, and it would go down. The only one they care about is first, second, and third. So that's what you're looking at. That's, if you were to draw it out, that's what it would look like. But this is a permutation. It's a permutation, God bless you, because we want a specific order of first, second, and third. So if you were going to use your calculator and your permutation button, you would say, okay, it's a P. How many, bigger number goes first, how many horses are in this race? 8. And how many different places are we concerned about? 3. So you do that in your calculator. You get the same thing. And again, we're going to practice this and the wording and understand what the question is asking. Yeah. Because they're talking about 3 different places, first, second, or third. What's the answer? What's 8 times 7 times 6? 336. Okay, so there's 336 different ways that these horses could finish. Exactly what I just talked about is what you guys just did. This is the permutation formula. It's just like the combination or the binomial coefficient one that you guys just did on your quiz without the extra R factorial. But you guys don't need this formula. You can just use your calculator. Yeah.
How do I put that in there?
Hit 8 and then PRB. And did you go to the P? Have it so the P is underlined. Yeah, the first one. Yep. Enter. And then 3. All right. Let's look at this. Permutations. Permutations. Order matters. Correct? Yeah? You guys with me on that? Permutation order matters. Well, now we're going to talk about something called a distinguishable permutation. And I know you guys are like, oh my gosh, just more words and stuff like that. Guys, distinguishable permutation just means you're going to have to account for repeats. What do I mean by that? A lot of times you'll see distinguishable permutations when they talk about words. They're going to say, in how many distinguishable ways can you arrange the letters in banana? Okay, so this is how we do this. It's going to be the total factorial over the repeated factorial. What this is accounting for is if you have the same letter more than once. Every time you're asked this question, it's going to be with letters. Sometimes it's random letters. Sometimes it's just a word that has, like, Mississippi. It's got a bunch of repeating in it. But when they ask for distinguishable permutations, it's the total amount of letters divided by the ones that repeat. So in the word banana, how many letters are there? 6. Okay, so it's 6 factorial over anything that repeats. So what letters repeat? A. Okay, how many times does A repeat? So 3 factorial. And then how many times does N repeat? So what this says, guys, is this says 6 times 5 times 4 times 3. Can I stop at 3 factorial? Yes. And then I have 2 times 1. But you can do this in your calculator. You can hit 6 and the factorial button, and then divided by, and then you have to put 3 factorial, 2 factorial in parentheses. Again, if you don't have a calculator or you're not sure how to do it, we can look at it in a second. But it would be 6 factorial divided by, and then in parentheses, 3 factorial times 2 factorial. Anytime you have distinguishable permutations, it's the total number of letters, factorial, divided by the repeated ones. Every single time. All right, now we're going to talk about combinations, and then we're going to be done. And then your web assign is not due until, I think, Thursday. I just want to practice this with you. You guys will see the different scenarios and when to use what. Yes, ma'am?
What was the final answer?
Yeah, because this would be 2, this is, yeah, 60 was. All right, in a combination, guys, order does not matter. This is the exact same formula that you guys just used on your quiz. You can now use your calculator. You don't have to write it all out or anything like that. But order doesn't matter. And again, the more you practice this, the more problems we see, you'll understand if order matters or if it doesn't. If you have a specific job, if you have a specific first, second, third, you have a specific order to things, it's a permutation. If everybody's doing the same thing, you're just on a committee, you're just throwing toppings on a sandwich. It doesn't matter if you put lettuce on top of cheese or mayonnaise on top of mustard, stuff like that. It doesn't matter the order that you pick your classes. All those sorts of things would be a combination when order doesn't matter. So if you look at a question like this, how many different ways, I know it says the word different, but how many different ways can 3 letters be chosen from these letters? And it says right here that what? The order of the 3 letters is what? Not important. So right away, that's telling you, oh, it's a combination. The order doesn't matter. So the bigger number goes first. How many possible letters are we talking about? 1, 2, 3, 4, 5. And how many are we choosing? So in your calculators, did you find your button? So you hit 5, and then find your C. Some of you might have to shift and find it. Some of you might have to go to your PRB. But get the C to come up, and then 3. How many different ways? What are y'all getting? 10? Okay, perfect.
Will it say the order isn't important?
Sometimes. Or sometimes it'll say, like, you'll see there's going to be a question that says, like, you know, trying to find certain people for a committee. Committee, if you're on the same committee, you're all the same job, that it's a combination. Like if you're trying out for a school play, everybody has different jobs, right? Somebody's the lead, somebody's this, somebody's that, it'd be a permutation. That's where it gets tricky. Right.
So it says the word is important, then PR.
Yep. If it says order is important, then it's a permutation. So it says a standard poker hand consists of 5 cards dealt out of a deck of 52. How many different poker hands are possible? After the cards are dealt, the player may reorder them, so order is not important. That means, oh, it's a combination. The bigger number always goes first. How many cards are possible in a deck? 52. And in your poker hand, how many are you dealt? It says 5. So it's 52 C 5. You get a big number. Yeah? What do you guys get? 2, say it like big kids. 2,598,960. Now, you guys are welcome to try and list those all out. Right? That's all you're doing right now is you're just listing out the possible outcomes. It might take you a minute or so to write down 2,598,960 different poker hands, or understand, oh, this is a combination problem, and I can just put out my calculator. So that is what the whole gist of 8.5 is. It's a permutation, it's a combination. Does order matter? Does it not? You guys are going to go through a bunch of different scenarios. You should look at your web assign before Wednesday night. Whenever I have it due, Thursday morning, just please look through it. I'm not going to be in here in class tomorrow, so you guys are going to work on the web assign. I will answer questions on Wednesday when you come in, but we're going to do probability on Wednesday, and then Thursday, Friday, Monday, Tuesday, we're just going to practice this. I know some of you are going to be out for the prayer walk and stuff on Friday. Like this stuff, you gotta practice.